Hello, welcome. Hi Dakshin, welcome aboard all my lovely warriors. Welcome my army. Hello Kalai. This is your captain Shreyas and welcome to the 12th standard Pathfinder series of ray optics. And today we are going to talk all about curved mirrors, that's concave and convex mirrors. So many problems to do in today's session. So get set go and go ahead and smash the like button for your favorite master teacher Shreyas. Yes, go ahead and guess what? Look at these dish antennas. Look at these antennas which are pointing towards different satellites. These surfaces are curved, and guess what? The concept of curved mirrors is also used right over here. The rays, electromagnetic waves which are incident on the curved surface, they get reflected and they collect and meet at the focus, and at the focus you have the receiver. So you will get a strong reception right over here. You might have seen these kind of antennas on the top of a building or dish TV, Tata Sky, whatever. It wants to collect all the rays at the focus. So it's a concept of mirrors. Remember, whatever you are studying in today's class is not just applicable for light, but it's applicable for all kinds of waves, be it light waves, be it electromagnetic waves, or be it even sound waves. It's just the geometrical aspect that you are studying over here. And you can click beautiful pictures in front of curved mirrors, and you can look fat, you can look thin, or you can totally disappear depending on where you are standing on how you are standing. Welcome all the lovely warriors. And that's what we're going to see in today's class. We're going to start with different kinds of spherical mirrors, the definitions, the terms. This is kind of a revision from your 10th standard syllabus. But after that, you're going to see a lot of interesting things like formation of images, and then also the magnification, but of two types: lateral, longitudinal, speed of image with respect to the object and the mirror, power and combination of mirrors. All of this in today's session with me, Shreyas, your physics master teacher. Hello Ankit, hi Ramya, hi Prakash, welcome the unknown, welcome EGL, hi Jayavant, welcome aboard. And while I see you every day, I get some motivation. That's very good EGL, and considering the fact that you are already enrolled into a course and college and you're still studying through YouTube, that's really commendable. Kudos to you. Hello Aditi, welcome, hi Subramaniam, welcome. So I hope you have also solved your homework from the last session, and in case you haven't, please do that after the class. After every class, I will give you homework. Okay, so keep that in mind. And welcome Balaji. So I have a surprise for all of you. You will probably notice it, or probably you would have noticed, you would have got a trailer of it just some time back. How many of you noticed it? Please raise your hand. And if you have not yet noticed, wait for it. You're going to see it in just few more minutes. Already I have done so much. Already I have switched to PowerPoint. You're going to see one more surprise today. And yes, if you want to know more about me, you can follow me on my Instagram handle out there. Yep. And I hope you guys have liked and shared and subscribed, because it's very important that you share this joy with your friends, relatives. Let them know about this channel. Let's make this channel grow, because only with your likes, only with your subscriptions will we get the motivation to conduct more such classes. So let's get started with today's session. And if you want to take more help from Vedantu apart from YouTube, you always have the help of Crash Course. This is a 90 session power packed series with assignments and with powerful tests, mock tests to help you analyze your performance. All of this comes with live plus recorded classes, and the best part is you can analyze your performance with the All India ranks, and you get the real picture of where you stand. All of this for just 9,000 rupees. It's there in the description box. There is a link to join the crash course. It starts in English medium and it will end much before your first attempt for JEE Mains. Now, let's talk about the spherical mirrors. So, a lot of people think concave and convex is different from spherical, but let me tell you, it's nothing different. Nice to see you too, Jitesh. Yes, the trailer. Well, Ankit, you might have seen a small glimpse of it. But probably now you will start seeing what I'm exactly talking about. The surprises are there plenty. I should have done all the things together so that it looks like a big dhamaka. I'm giving you chotu motu surprises. I think I should do all of them together. Hi Narbavi, welcome aboard. Welcome Jonas. Now, depending on which side you silver, you get two kinds of mirrors. One is concave, one is convex. Spherical mirror is a mirror whose surface is spherical, but a concave mirror need not be spherical in nature. Let me remind you of that. See, if I have a sphere and if I silver one side, I will get a convex or a concave mirror. But if I have a concave mirror, it need not be a part of a sphere. It could be a part of cylinder. It could be a part of something else. So concave and convex is a more general term. Spherical mirror is a more specific term. Are you guys understanding that? Are you guys understanding this? Yep, that's very important for you to get to know this. Okay, so the spoon, when you see it from this side, it's concave. When you see it from the other side, it's convex. And it's just a concave or convex mirror. Whether it's a part of a sphere or not sure about that. But in JEE, we only have spherical mirrors. So depending on which side you basically silver. So if you silver the outer surface, the inner surface will become concave. That's a concave mirror. And obviously if you silver the inner part, the outer surface becomes reflecting. That will be then termed as the convex mirror. Now, the different points that you should know about, a concave or a convex mirror. So what are those points? Number one, look over here carefully, my warriors. First of all, quick revision. This is all a revision of 10th standard. Then we are going to go to a 12th standard class. So when you have a mirror and if you complete the sphere, the center of the sphere is called center of curvature. The radius of that sphere is called radius of curvature. Same thing is applicable for even concave mirror. So if this is a concave mirror, if you complete the surface, it looks spherical. The center of that sphere is center of curvature. And the radius of such a sphere is called radius of curvature. Keep this in mind. Very standard definition. C, etc. C, R and P. What is P? P is called as the pole. Pole is the center of the mirror. As simple as that. Next, focal point. If you have a concave mirror, it is converging in nature. If you have a convex mirror, it's diverging in nature. So for concave mirror, when the rays are parallel and they are incident on it, they all meet at a point that's called as the focus. But for a convex mirror, when parallel rays are incident, they diverge from a point behind the mirror. That's the focus of the convex mirror. So remember one thing. For concave mirror, it is basically converging. That's very important. It's converging in nature. And this is nothing but diverging in nature. Very, very interesting. Well, I hope you have realized what the surprise is by now. And yep, did you realize? Yes, Ankit looks like he realized it. All right. So next important thing, how do you find the image which is formed by concave and convex mirror? There are just 3 rules for drawing the ray diagram. Remember, I had told you, whenever you want to find the image because of any object, for any surface, doesn't matter, reflecting, refracting, you need at least 2 rays to locate the image. Only when those 2 rays intersect will you be able to locate the image. So now what will happen is, when you want to locate the image because of concave or convex mirror, you need to know how the rays will travel. Now just imagine, when you have a concave or convex mirror, there will be so many rays, they will be reflecting in so many different directions. How do you exactly locate where the image is formed? So it will be better if we have some kind of a rule right over here. Just one second. Okay. Yes. So if you have some kind of a rule, and that rule is very simple. Use one of these 3 rules to locate the image. The first rule is, if the ray is parallel, then it will pass through the focus, or it will diverge from the focus for a convex mirror. That's very obvious. If the rays are parallel, then it will pass through the focus, or if it is convex mirror, it will also pass through the focus when extended backwards. This will give you one of the rays to locate the image. Another ray that one can draw is a ray which passes through the focus. After reflection, it will become parallel. Very interesting. A ray which is going to pass through the focus. This is the focal point. Then after the reflection, it becomes parallel. For convex mirror, if the ray is incident towards the focus, it becomes parallel. So again, it is incident towards the focus, it becomes parallel after the reflection. I hope you realize both these things are equivalent, because if you reverse the direction of light, then the reflected light becomes incident, the incident becomes reflected. It's one and the same thing. This comes from the principle of reversibility of light. Reversibility of light. Is that clear, my warriors? Very good. Very good. EGL, can I pronounce? Amuku, Dumuku, Amala, Dumal. Is that how it is? Amuku, Dumuku, Amal, Dumal. Yep, that is it. Yep. Yes, EGL, did you not realize it? I have shifted to dark mode so that it is pleasant and it's convenient on your eyes. I have shifted to dark mode. I'm trying it today, and if you're loving it, you need to put it up in the comment section after the session ends. The third rule is, if the ray passes through center of curvature, it rebounds back in the same direction along the same line. Be it concave, be it convex. If the ray is incident towards the center of curvature, it rebounds back along the same path. Keep this in mind. Now, why is this true? Because when the rays are incident from the center of curvature, it passes along the radius, and the radius is always perpendicular to the arc or the circle. When it is perpendicular, the reflected and the incident ray will be the same. So the incident and reflected rays are same. That's because the rays are incident perpendicular to the surface. Is that clear, all my warriors? Understood? These are the three rules that you are going to use to locate any particular image. So for example, if you had some kind of a mirror like this, say, if you had some kind of a mirror like this, and you wanted to locate its image of an object, all you need to do is draw certain rays. So let's say one ray could be parallel and it passes through the focus. So maybe this is the focus. You can draw another ray, alright, you can draw another ray which probably passes through the focus, and after reflection, probably it becomes parallel. So now you know they intersect over here. So hence, this is our final image. So this is our final image. That's how you locate any image. Is that clear, my warriors? Jones, I'm already doing one shots for 11th standard. It was done yesterday. I'm going to do it tomorrow as well. So simple ways: draw any one ray, the second ray, see the intersection, and that's it. If you want to verify it, then you can draw the third ray, but it is not necessary or mandatory. All right. Now, in your 10th standard, have you drawn the different positions of an object in front of a concave and convex mirror? Have you done that? And you would have made a beautiful chart or a table. Oh, when you place it here, then the image is like this. When you place it here, then the image is like that. For both concave and convex mirror. How about showing you how it looks like right over here? Look at this. This is a beautiful simulation of that. It's a beautiful animation of that using physics. So this is your curved mirror, like you can see. This is my object. This is my image. This is my focus. Fair enough? So I can shift the focus right over here. Let's say I make the focus here. Now look at this object. Look at this object. If the object goes far away, I'll just take this object a little bit far away. See where the image is formed. The image is formed very close to the focus. So if I shift this object really far away, you will see the image will be formed on the focus. Okay, let me just change the focus to some other point, maybe somewhere here. So you can see as the object goes far away, the image will be formed at the focus. And a very important thing that you should know, R is equal to 2F. Very important relationship in case you do not know about it. The radius of curvature and the focal length have this relationship. R is equal to 2F. Very important. R is the radius of curvature. F is the focal length. Our radius is always twice the focal length, and you will be able to see that in very simple and different ways. Like, say for example, I keep moving this, okay? I keep moving this object, and now if you place the object at the center of curvature, see, if I place the object at the center of curvature, the image is formed at the center of curvature, because all the rays which originate from the center of curvature will reflect back at the same point. It will reflect back at the same point, and the image is exactly formed here, but it is inverted. So you can see this is the center of curvature right over here in this situation. This is the center of curvature. This is your focal point, and you will see in this case the focal length is basically 3 units, whereas the radius of curvature is nothing but 6 units. So you can clearly see R is equal to 2 times of F. Are you able to see that, my warriors? All right, great, amazing. And you can see when you place the object somewhere in between center and the focus, the image is formed here. It is enlarged, and as you place it on the focus, you will see the image will be formed at infinity. There is a very special case over here when you place the object between the focus and the pole. Do you see that special situation when the object is here? Look at where the image is formed. This special case is where the image is erect and it is virtual because it is on this side. Please understand, when the image will be formed on this side, on this particular side, this will be real, whereas this will be virtual. This will be virtual because it is formed behind the mirror. This is behind the mirror, and this is in front of the mirror where the rays actually meet. Do you see that? I hope this is clear. Very good, very good. Yeah. Yes, you have any doubt, please let me know. And let me also remind you, there are all kinds of people who want to know from the basics. Some of you might have learned this very well in your 10th standard, but it's a good point to revise all these things. All right. Now, this is a very special case, like I have told you, when the object is between focus and the pole. Now, if you shift the object onto the other side, the mirror becomes convex. Because if I go here, this is the concave side. If I go on to the other side, the mirror becomes now convex in nature. It becomes the convex in nature. And you will see if the object is placed here, the image is formed on this side. The object is placed here, image is formed on this side. In this situation, this side is the real side and this side is the virtual side. This is the virtual side because this is behind the mirror. This is behind the mirror and this is in front of the mirror. Make sense? Do you see that when the object is placed in front of the convex mirror, the image is, obviously it is erect. The image is erect and it is diminished and it is virtual. It is erect, virtual and diminished. This is the interesting thing about convex mirror. No matter where I put this object, you are always going to see the image being formed over here, which is diminished, which is virtual, and it is erect. That's one interesting property. Yep. Okay. I hope this is clear. Very good. Interesting. Now, going back, I have put it up all in the slides for all of you. So I want you guys to practice it. Just one second. Where did it go? Yep, it should have opened. Yep, I have put it up on all the slides where the object is and where the image is formed in the ray diagram form. Use the rules of drawing the ray diagram and practice it at home. Don't ignore this because you don't know how this can be very helpful in the examination hall. I have also put it up in the tabular form for concave mirror. So where is the object, where is the image, and the nature of the image. All of this in the table. Try each and every case at home. This is your homework. Please try it out. It will not take you more than 15 minutes for both concave and convex mirror. Look at this situation. And this is a very, very important example. You would have seen that in your 10th grade. But I wanted you guys to visualize this. If you have visited the dentist, he uses this concave mirror. And what he does is that when he uses the concave mirror, he makes sure that the teeth is between the pole and the focus. So what has happened over here is basically the teeth is between the the focus and the pole of that mirror. So when this is the object, you will see that this object's image will be formed over here, and this will be virtual and it will be enlarged. It will be virtual, enlarged, and also erect. So that means if you see from here, you're going to see this teeth here, and you're going to see it big, enlarged, and erect. That's what it is. Important. Very good. Yes, I'm using Apple Pencil. Look at that. I have shifted from this big fat pencil which I used to have, and I've shifted to Apple Pencil because this is easier to write. Alright, it doesn't matter how I write on this board. I can even write it using my finger, but yes, I don't want to use my finger out there. Alright, for convex mirror, again I have put up all the ray diagrams, and I have also put up the cases for convex mirror. For convex mirror, it is always diminished, it's virtual, and it is erect. That's what you should know. Only when it is at infinity, then the image is formed at the focus. That's a special case. And where do you use a convex mirror? Yep. Ray optics, Venkat. Yep. And when do you use a convex mirror? When you want to see many things in a small area, like the rear view mirror or in a parking lot. So this convex mirror will make sure whatever is behind you, okay, so you are driving this car, okay, and like this, whatever is behind you, the image is virtual. Why do you want virtual? Because obviously if the image is real, then you will need a screen to see it. Obviously you're not going to hold a cloth, a handkerchief over there and see where is the image formed, right? So you need the image to be virtual, and it is diminished. So many things behind you are portrayed behind the mirror in a small area. Okay, so that's what happens when you use a convex mirror. And yes, that's why they say the objects in the mirror are closer than they appear. Yep, because it's all small and it all looks closer. Alright, let's see if we can solve this question coming up on your screen right away. There is a person, he sees his virtual image by holding a mirror, and it is very close to the face. When he moves the mirror far away from his face, the image becomes inverted. What kind of mirror do you think he is using? Yep, let's see. Yes, Prakash, at hairpin bends near the mountains. Do high weightage topics in PCM for JEE Advanced, because it will be, yes, Ramya, I'll be doing it. First, let me complete the syllabus. And anyways, I'm doing the high weightage topic. Ray optics is very high weightage. Whatever I'm doing right now is high weightage only. Oh, by the way, for JEE Advanced, there is nothing like low weightage and high weightage, because JEE Advanced can just mess around with people. They can just change the pattern. They can just do whatever they want. Very good. Oh, Ananya, you're saying it convex? Nope. Okay, all right, fine. Whatever your suggestions are, Easiel, please let me know after the session is over in the comment section. If you don't like this violet, please let me know later on. If you don't like this green, please let me know. If you don't like this blue, please let me know. If you don't like this black, please let me know in the comment section. This is the first day, I'm just trying it out, okay, just a design. If you find something better, please let me know which I can use. All right, yes, it is concave mirror, my warriors. Concave mirror, the object when it is between focal length and the pole, that time the image is virtual, and when the object shifts beyond the focal length, then the image becomes inverted, it becomes real in nature. So it has to be concave. For convex, it is always virtual, it never becomes real. All right, for actual objects it's always real, hence it can be only a concave mirror, because it becomes inverted. Earlier it was virtual, all of that. Great. Okay, great. Acha, everybody is liking white. Interesting. Okay, fine. Okay, so what is the sign convention that you have? All right, so this sign convention is going to be very helpful when you are going to apply the mirror formula, lens formula, anything that you're going to apply, magnification, you are going to need the sign convention. Now many students think right side is positive, left side is negative, up is positive, down is negative. That is completely wrong. If you have been told like that, that is wrong. Okay, now let me tell you how the sign convention works. Listen in carefully. First of all, remember, if the object is here, now this is the object, right? This is the object. The rays of light will be traveling like this from the object, right? The rays of light will be going like this, and then it will be getting reflected from the surface. They are moving that side like that. Keep that in mind. Next, pole is always the origin. This is always the origin. Keep this in mind. What is the pole? The pole is always the origin. Next thing, if this is the origin, then one side must be positive, one side must be negative. The direction in which the light rays are incident. See, where are they incident? These are the incident rays. This direction is positive. So hence, this is the positive side and this becomes the negative side. Okay. Sorry, not this one. My bad. Oh, I can't erase this, but this one. This is the negative side. That becomes the positive side. That becomes the negative side. The direction in which the incident rays are going. Now, usually upwards is taken positive, the one on the top, and the one which is down is usually taken negative. Up and down there is no confusion. The main confusion happens between right and left. Right is not positive. The direction of incident is positive. So let me just put it up right over here. The direction of incident ray. I'll just put it over here. The direction of incident ray is positive, irrespective of anything else. Keep this in mind. Okay, I hope this is clear. Now, let me see if you can understand it with these simple examples. Let me draw few mirrors and some positions. Let's see if you guys can get this. Okay, so I'm just drawing few examples right over here. Okay, let's see if you guys can figure this out. Okay, great. Right, so I've just drawn few concave and convex mirrors. Let's say, for example, okay, there is an object which is placed over here. This is an object which is placed over here. And let's say the image is formed right over here. What do you think the object distance will be? Will it be positive, negative? Will the image distance be positive, negative? And will the focal length be positive or negative? Think about it. Think about it. Yes, the direction opposite to the incident ray is considered negative. Yes. Yes, correct, Ankit. Okay, Aswait will complete this chapter in the next maximum 1.5 weeks. Alright, so what do you think is the object distance going to be? See, look at the incident rays. The incident rays from the object are going like this. These are the incident rays. This is your origin. So that means this must be the positive side, this must be the negative side. From this you will get the answer. So image distance, you can see the image distance will be positive, the object distance will be negative, and the focal point of this mirror, where will be the focal point? Focal point will be here. So the focal length will be also negative in nature. Everybody clear about this? Very good. Similarly, for this particular example, let's say the object is over here and let's say the image is over here. In this particular situation, again, if you draw the rays which come out of this object, the rays will come out like this. So these are the incident rays and the incident direction is always positive. So on this side you will get positive and on this side you will have negative. This is the positive side, this is the negative side. So again, what am I going to get? Let's see. So the object distance will be negative, the image distance will be positive, and the focal point will be somewhere over here, right? So the focal length will be nothing but positive. Is that clear, my warriors? Is that clear, my warriors? Very good. Let's take up one more example so that I am sure that you guys have understood this. Let's say the object is over here. This is your object, and let's say the image is over here. Example, let's say this is the object, this is the image for a concave mirror. Now we all know that the focal point will be somewhere over here. Now in this case, what do you think will be the sign of object? What will be the sign of image distance be? A lot of students are going to make a mistake over here. Many people will think, sir, object is behind the mirror. How will it even reflect? Agree. If a real object was behind the mirror, then it will not reflect. But the fact that I have drawn an object means it could be any kind of object. Maybe it is not real, maybe it is virtual object. What do I mean by virtual object? So if it is virtual, the rays of light are actually converging to make that object. The rays of light are actually converging to make that object. Very, very important. I hope this is clear. So this is the direction of incident rays, and this object is not an ordinary object. What kind of object is it? It's a virtual object. It's a virtual object. That's what. Hence, in this case, what will happen is, if this is the direction of incidence, then this side will be positive, this side will be negative. This side is positive, that side is negative. And what am I going to get? The focal length will be negative. Then what is it? Your object distance u will be positive, and the image distance v will also be positive. Is that understood, my warriors? I hope this is clear. So this is a virtual object. That's what you should understand. The rays want to meet over there, but they will get reflected and they will form the image somewhere else. They'll form the image somewhere else. I hope this is clear. In the first case, what is the sign of focus? In this case, the focal length is negative, because you can see this is the focal point, this case. So this is on the negative side. That's why focal length is negative. I hope this is clear. Oh, yeah. So they appear to meet at the point. Yes, Abhishek, they appear to meet. Remember last lecture I had told you the definition of virtual object, virtual image, real object, real image. So this is the rays which want to meet over there, but they are not able to meet. So wherever they appear to meet, that's where there will be a virtual object. For this situation, okay, for this situation, the fourth situation, let's take another example. Let's say, okay, so let's say this is our object. Let's say this is our object, and let's say, I don't know, maybe this is your image. Maybe this is your image. And then, of course, your focal point, I don't know, maybe this is your focal point, for example. In this situation, again think, your mirror is facing that way. This is the silvered side. The object is behind the mirror. If the object is behind the mirror, how will it reflect? Unless and until it is a virtual object. That means the rays are coming like that in order to form the object over here. This is your incident. This is your incident ray. And if the rays are going like that, this side will be positive, this side will be negative. Now it becomes very, very clear and obvious. The focal length, what will it be? It's on this side, so it is basically positive. The focal length is positive. But if I talk about the image and the object distance u will also be positive, and the image distance v will also be positive in nature. Got it? Isn't it easily done now? Once you know the rules. So these kind of rules are very important. These things you do not learn in your lower grades. These things you don't learn in your lower grades. Now that you know it, you will never forget it. This is how you use sign convention. It's also applicable for lenses, for combination of mirrors, lenses, everything. Great. Okay, so let's move on to some questions, but before that, let me tell you, whatever I write in the slides, it's all there. Whatever I write over here, it's not going to disappear. It's all going to be all there on our Telegram channel. Make sure you join the Telegram channel as soon as possible so that you do not miss the PDF, the solution of the homework problems, also the updates and important notifications. Mirror equation. Very important. Now things are going to get interesting. Let's see. Very good, Nikhil. So, what's the mirror formula? See, every time you cannot draw the ray diagram to find the image. You might make some errors, you might not have a scale, and it is not accurate. So, you should have a numerical way to form where the image is, how the image is, and all the other details of the image. So the mathematical way is done via the mirror formula. And what is the mirror formula? It is 1 by v plus 1 by u is equal to 1 by f. As simple as that. And remember this again, r is equal to twice of f. Okay, r is equal to twice of f. What is v? V is your image distance. U is your object distance. All of this, F is your focal length, of course. F is your focal length, and all of this has to follow the sign convention. This has to follow sign convention. If you do not know the sign, leave it as a variable, like you used to do in kinematic equations. If you don't know something, just leave it like a variable. Automatically you will get it with the correct signs. As simple as that. 1 by V plus 1 by U is equal to 1 by F. Let's do a question on this. An object is placed on the principal axis of a convex mirror of a radius of curvature 60 centimeter at a distance of 10 centimeters from the pole. Find the position and the nature of the image. Let's do this, and if you guys are fast, please do this before me. I'll be explaining it in the next few minutes. Before that, if you can solve it, well and good, and post the answers in the comment section. I'll be reading all of them. Alright, so get ready. Let's start solving these questions. So first of all, what and all do we know? Let's put it up. The object is placed on the principal axis, convex mirror, radius of curvature 60 centimeter. So if it's a convex mirror, okay, if it's a convex mirror and radius of curvature is 60 centimeter, and we know radius is twice of F, so F will be 30 centimeter. And for a convex mirror, we all know that the focal point will be somewhere here. This will be the positive side, so this should be the plus 30 centimeters. Everybody fine with this particular point? Okay, focal length is 30 centimeters. Now use the mirror formula and let's see what do we get. Using the mirror formula, 1 by V plus 1 by U is equal to 1 by F. Therefore, 1 by V, I do not know V, plus 1 by U. U is given, the object distance is 10 centimeters in the front. This is where you place the object, and this object distance will be negative. Keep in mind, because that side will be positive, this side will be negative, because the rays of light will be coming like that. So object distance will be negative, so minus 10 is equal to 1 by F, F is 30. So therefore 1 by V is equal to 1 by 10 plus 1 by 30. Take the LCM, so it will be 30, so it will be 3 plus 1 divided by 30, which is 4 by 30, which is 2 by 15. So V will be nothing but 15 by 2, which is 7.5 centimeter. Now since the answer is positive, that means the image will be formed somewhere over here. And if the image is formed over here, what kind of image will it be? Will it be real or virtual? Because we have been asked what is the nature of the image. Hence, think about it. If it is formed behind the mirror, it will be virtual in nature. So it will be virtual in nature. So that's it. We have got it. Perfecto. Very good, the unknown. Very good, Ankit. Excellent. All right. So very good. Very good. Excellent. Let's move on to the next question. Coming up on your screen. Yes, 7.5 centimeter virtual. Many of you got it. Excellent. Now, magnification. Next formula coming up on your screen. When you place an object, the image which is formed can be enlarged, can be diminished, or can be of the same size. It can be erect, it can be flipped, which is inverted. All of this you will understand via the magnification formula. The image height by the object height is simply put the magnification. So what is magnification? Magnification is basically the image height divided by the object height, and this turns out to be minus of V by U. It turns out to be minus of image distance by object distance. Keep this in mind. Do not forget the minus sign. So image distance by object distance with the negative sign is the magnification. This magnification happens perpendicular to the principal axis. Look at this again. I will mention it right over here. If this is your principal axis, this magnification is happening perpendicular to the principal axis. Sometimes it is also called as the transverse magnification or lateral magnification. Okay. Now I'll tell you what does the meaning of magnification actually stand for. See, observe these examples. Take these examples. Okay, these are some examples. If the magnification is +2, it means the image is twice the object size. So obviously it is enlarged. Obviously it is enlarged. The plus stands for that the image height and the object height are in the same direction. The image height and the object height, if they are in the same direction, that means the image is erect with respect to the object. Is that understood, my warriors? Very good. Similarly, let's take another example. Let's say the magnification is -0.3. Look at the magnitude. Forget the minus sign for now. 0.3. Image is 0.3 times the object. That means it is smaller. It's less than 1. So hence the answer will be, it is diminished in nature. It is diminished, and that negative sign stands for inversion. The image and the object heights are opposite in direction, so it is basically inverted in nature. Got it? Another example. Let's say the magnification is -1. That means the image is of the same size. The image is of the same size, and minus stands for inversion. So the image is inverted in nature. That's how you can get it. I hope this is clear. Okay, EGL, I'll reply to that after the session is over because I don't want to break the flow. All right? Yep. So can we say the image is virtual or real by magnification? No. You can figure out whether the image is real or virtual, the unknown, only via the image distance, not via the magnification. Via magnification, the only two things that you get to know is whether it is enlarged, or whether it is diminished, okay, whether it is diminished or whether it is of the same size. That's one thing you get to know. And the second thing that you get to know is whether it is erect or whether it is inverted. These are the only things that you get to know. If you want to talk about whether it is virtual or real, so the virtual and real aspects you only get to know via the image distance, not via the magnification. Got it, my warriors? Very good. Yes, Ishwar, it is there in the Pathfinder playlist. It will be there at the top or at the bottom. Just scroll through it. Okay, probably at the end I will show it to you. When the session is nearing the end, just remind me. I'll show you how to browse and get any lecture that you want. Okay, great. Moving ahead, let's see if we can solve this question coming up on your screen. When it's of the same size, yes, when it's of the same size, the magnitude will be 1. The magnification will be 1 or -1. 1 means erect, -1 means inverted. That's the meaning of same size. Is that okay, Ankit? Moving on to the question coming up on your screen. There is an object 5 centimeters tall. It is placed 1 meter in front of the concave spherical mirror, which has a radius of curvature 20 centimeter. The size of the image is how much? Is it inverted? Is it erect? What do you think? Okay, let's try and solve this. Come on, my warriors. Okay, so let's start solving this question. So first of all, think object height is given. Object height is given, and we have been also given the radius of curvature. Size of the image has been asked. Let's draw a rough diagram to just understand what is exactly happening. So it's a concave mirror, I suppose. Yes, it's a concave mirror, and the object is somewhere over here. This is the object, and the object distance is given to be 1 meter, I suppose, somewhere. Yes, it is placed 1 meter. That means it is 100 centimeters, but this will be negative side. This will be the positive side. Since it's a concave mirror, the focal point will be somewhere on this side, and R is 2F. So radius of curvature is 20. So it's actually -20 because it's on this side. Will be equal to 2F. So F will be equal to -10 centimeters. That's what I get, the radius of curvature. Next thing, let's start with the mirror formula. So 1 by V plus 1 by U is equal to 1 by F, because I want to find V. Okay, let's see. 1 by V plus U is -100 is equal to 1 by focal length. Focal length is -10. So therefore 1 by V is equal to 1 by 100 minus 1 by 10, which is 1 minus 10 divided by 100. After taking the LCM, So this will be minus 9 by 100. So therefore, V will be minus 100 by 9 centimeters. Now, if you get V as minus 100 by 9 centimeters, minus means on this side. Is the image virtual or is it real? Think about it. Is the image virtual or is it real? It's on this side. So obviously, if it is on this side, the image is formed here in front of it. So hence it will be a real image. So that's one thing I got. The nature of the image, etc. Next thing, I'll figure out what is the inversion or magnification. So magnification is minus V by U. So it will be minus of V, which is minus 100 by 9. The whole thing divided by U. U is minus 100. Minus 100 minus 100 cancels. So it will be minus 1 by 9. That's your magnification. Now once you get this, you clearly know it is inverted in nature and it is less than 1. So it is basically diminished. So it is diminished and it is inverted. And the last thing, what is the size of the image? What is the size of the image? The size of the image also can be found out. It's not that difficult. Magnification is known. So the magnification will be image height by object height. So image height I do not know. Upon object height, that is 5 centimeter. Okay. So from this image height, magnitude wise, I'm not interested in the direction and all that, will be just 5 by 9. 5 by 9, you can do the math. Yeah, 9 5s are 45. Yeah, 9. Yep. So what are you going to get? Are you going to get 0.55 centimeters? Come on. Are you going to get it? 9 5s are 45. So 0.555. That's what you're going to get. Very good. Yes. Excelente. Excelente. Very good. So that's the answer. It's 0.55 centimeters. It's inverted. It's diminished. It's also real in nature. Okay. We also got it as real. We also got it as inverted and diminished. That's how you're going to solve the problems. Next question coming up on your screen. A concave mirror has a focal length of 20 centimeters. The distance between the two positions of the object for which the image size is double of the object size. Very tricky questions. Till now, we had decent questions. It was more like 10 standard. Many people were like, sir, go fast. Hold on, we are coming there. Amazing questions, advanced mains questions coming up now. Let's see how many of you can do this. Now, the magnification is going to be twice, but there is a catch. If the image size is double, it means the magnification can be +2 or it can be even -2. There are two possibilities. One time it will be erect, second time it will be inverted. Both the times the image size is twice. There is no mention of whether it is erect or inverted. So for each sign, I will get two object positions. I'll get two object positions. That's why the question is, find the distance between the two positions of that particular object. First time you will get +2, next time you will get -2. The way I approach this question is very tricky, is very interesting also. Observe this. I know that magnification is -V by U. So somehow let's find V. And see what do we get. 1 by V plus 1 by U is equal to 1 by F. Therefore 1 by V is equal to 1 by F. Take this term over there. So it will be -1 by U. Now take the LCM. It will become U minus F divided by FU. So that will be 1 by V. So therefore V will be equal to Fu divided by U minus F. Take this value, put it over here. So let's see what do we get. -1 by U is as it is. Instead of V, put Fu divided by U minus F. Fu divided by U minus F. U will get cancelled and I'll have -F divided by U minus F. So I'll just put it over here. So the magnification will become, take the minus sign inside, F divided by F minus U. That's it. I have got this relationship. I'm going to make use of this fact. Let's see how. Observe now. Okay, just observe. First time let's take +2. Next time we'll take it as -2. First time we'll take it as +2. Next time we'll take it as -2. Okay, I hope this is clear. Thank you. Glad to know that, Rishi R. I'm so happy that we are helping you. Guys, I am going to launch something very crazy probably in the next 1 or 2 days, and I hope you're going to love it very soon. Just wait for it. Okay, on this channel itself you're going to have some very interesting things coming up. All right, now let's see. If I take magnification as +2, what do we get? 2 is equal to focal length. Focal length is 20, but it's a concave mirror, don't forget that. So for concave mirror it is negative. Okay, so for concave mirror, remember the focal length is always negative. So let's just substitute that. So minus what is it, 20, right? Yes, minus 20 divided by minus 20 minus u. Okay, just rearrange this. So this will become minus 40 minus 2u is equal to minus 20, correct? So shift 2u on the other side. So you will get 2u is equal to minus 40 minus 20 will become plus 20. So minus 40 plus 20, right? So what are you going to get? You are going to get this as minus 20. So therefore u is going to be minus 10 centimeters. So the first object distance we got it as minus 10 centimeter. Fair enough. Now going ahead, let's take the magnification as minus 2 and see what do we get. Instead of plus 2, let's take it as minus 2. So minus 2 is equal to minus 20 divided by minus 20 minus u, correct? Everything else is same. I'll get a new object distance. Let's figure this out. Okay, so this will become minus into minus will become plus. So it will become, okay, it will just become 40. It will become 40 plus 2u is equal to minus 20. So basically shift 40 on the other side. So 2u will be equal to minus 20 minus 40, which is minus 60. So u will be equal to minus 30 centimeters. That's it. Now we have the last step. First time I got the object distance as let's say minus 10. Second time I got it as minus 30. So one time it is minus 30, one time it is minus 10. So what is the difference between this position 2 and position 1? It is obviously 20 centimeters. Hence the correct answer is option A. Got it? I hope this is clear. Yep. Definitely, Ishwar, it will be coming. Just hold on. You need to have patience. It's not like you tell me, sir, I want telescope, microscope, I want it tomorrow. Sir, I want modern physics tomorrow. I can't do that. Sorry, it's not possible, boss. Okay, you need to wait for it. Okay, because we have to do it in a particular sequence. Yep, interesting. Yep. So, Rishi, I will do something like that for Olympiads or something. I will tell you what it is in a bit. Probably just wait for 1 or 2 days. You will see it on our channel. Okay, you will see some very interesting thing coming up from my side. You wait for it. Okay, something which is very challenging, not easy peasy stuff. All right, so that's where we go. That's the answer. Moving on to the next question. This is one of the brilliant questions. Very good question. Which of the following is are possible? That means advanced type, more than one may be correct. For a curved mirror producing inverted image. Producing inverted image. Yes. Okay, definitely, Ishwar. Request is considered. It's already in the plan. So for producing real image. Let's see how many of you can do this question. Sorry, not real image, inverted image. More than one may be correct. Think carefully. This is a curved mirror and you have to produce inverted image. Which of the following is possible? AB, BC, CD, ABC, BCD, ABD, ABCD, or just A, or just B, or just C, or just D. I don't know which one of them are correct. Think about it. Arjun, join in. You missed the fun part in the initial stages, but I hope you are able to catch up. And if you're not able to catch up, just go back a little bit and catch up at 2x speed. Even in a live class, you can do that. See, the image is inverted. And what did I tell you about inversion or being erect? It's all determined by magnification. So, if the image is inverted, that means the magnification is for sure negative. The magnification is for sure negative. Got it? But what is the formula for magnification? The formula for magnification is minus V divided by U. Now, if this is a negative number, if M itself is negative, so think about it, if this is negative number, how should the signs of V and U be? Or what should be the signs of V and U be so that the magnification turns out to be negative? Think about it. V by U ratio should be positive. V by U ratio should be positive. Correct, my warriors? V by U should be positive. Agreed. Because there is a minus sign. You want a minus sign on the left hand side because it is inverted. So the ratio should be positive. If the ratio is positive, that can only happen in two scenarios. Scenario 1, V is positive and U is also positive. Scenario 1. Second scenario, V is negative and U is also negative. Both are negative or both are positive. Agreed with this? Now, if both are positive, that means both image and object, both are, think, which is the positive side? It's nothing but virtual. It's virtual. And if both are negative, then it is real. Hence, both are imaginary or both are virtual or both are real. That means option A and option B. That's what you are going to get, A and B. Isn't it interesting? What a brilliant way of solving this question just via the formula of magnification. So object and image are real or object and image are virtual. But if one is virtual, one is real, or the other one is real, this is virtual, then the signs will be opposite. The image will not be inverted, it will be erect. That's how it is. Superb, right? Amazing, right? Yes, Ajay, it is already there. The playlist is there. Wait till the end, Ajay. Somebody else also asked me, please show the playlist. I'll show it to you towards the end. Hold on for that. Okay, perfecto. Moving on to the next question. But before that, velocities. Let's talk about it. See, when the object moves, the image will move. And you will find questions where the object is performing SHM, or there is relative motion, there is a cart which is moving towards the mirror is placed on some elevator, it is moving, and you might have to find where and how the image is moving. That's what we are going to see in the relation between the object and the image velocity. And there is very easy way to find that out, believe me. All you need to do is differentiate. I'll tell you why. See, if V happens to be image distance, then dV by dt will become image velocity. Rate of change of image distance will become nothing but image velocity. I can just put V with subscript I standing for image. Similarly, if U is nothing but object distance, then du by dt will become object velocity. I'll just call it VU. Rate of change of object distance, dx by dt is velocity. That means somehow I need to get to derivatives. How do I get to derivatives? That's simple. Remember, 1 by V plus 1 by U is equal to 1 by F. Just write it in a slightly different way. How? Look at this. V raised to minus 1 plus U raised to minus 1 is equal to 1 by F. Now, differentiate both sides with respect to time. With respect to time, you differentiate both sides. So it will become derivative of V raised to minus 1 plus derivative of U raised to minus 1, and derivative focal length is a constant, so the derivative will be 0, okay, because it's a constant. So for a constant, the derivative will be 0. Very simple. Now V raised to minus 1, with respect to V, you can use nx raised to n minus 1 formula. But since the variables are different, you need to use the chain rule, and if you remember derivatives clearly, you will get it very easily. It will be V raised to minus 1, x raised to n formula, use x raised to n formula, nx raised to n minus 1. So n is minus 1 into x raised to n minus 1. So V raised to minus 1 which is minus 2 into chain rule dV by dt. So using chain rule you will get this. Similarly over here you will get minus 1 from here. So minus 1 into U raised to minus 2 into du by dt is equal to 0. Now just play around with this, you're going to get whatever you require. Let's do that. So minus dv by dt is image velocity, so that's nothing but vi, and v square will come below, minus du by dt, that's object velocity, so vo divided by u square is equal to 0. Just play around with it little bit, see what you guys get. Shift one thing on the other side, so vi by v square will be negative of vo by u square. Rearrange, you will get vi by vo will be minus v square by u square. This is exactly what I wanted. This is exactly what I wanted. Very, very important. So basically it says image velocity by object velocity is negative of v square by u square. Remember, just magnification, your normal magnification was minus v by u. The image by object velocity will become minus v square by u square. What is vi? I have mentioned it over here. It's the image velocity. Vi is image velocity, Ishwar. I have mentioned it right over there. Okay, so vi by vo, image by object velocity is minus v square by u square. Now, instead of, writing dv by dt as image velocity, du by dt as object velocity, instead, if I would have played around with it little bit differently, I'll tell you how. Forget that dt, just forget that dt, see what do you get, just see what you get, minus, okay, 1 by v square, forget that dt because dt will cancel, into dv minus 1 by u square into du is equal to 0. Okay, let's just shift it over there. So I'll get dv by v square is equal to minus du by u square. Rearrange it further, dv by du is equal to minus v square by u square. It's the same formula. It's the same formula what you got. But this dv by du is a very interesting thing. dv stands for the change in the image position. du stands for the change in the object position. Meaning that if you had a mirror, something like this, okay, if you had a mirror something like this, then du stands for if there was an object measuring this much length du along the principal axis, then its image dv along the principal axis will look something like this. dv by du stands for, understand, the image width and object width along the principal axis, because u or v measures distance. So du and dv are all along the principal axis. So this becomes basically the magnification along the principal axis. This is along the principal axis. Along the principal axis. That's why it is also called as the longitudinal magnification. What is it called? Longitudinal magnification. And the formula is the same as that of image velocity upon object velocity. Yep, it is just the square of your lateral, perpendicular, transverse or your normal magnification. It's just the square of that with the negative sign. Correct. Got it, my warriors? Got it, my army? Got it, everyone? Lovely, isn't it? The derivation is so pretty and beautiful. It's all there, and if you want it in the printed form also, I have kept it, and I have also kept it on this slide as well. Okay, so don't worry about it. It's all there right over here. Now there's only one thing which I need to tell you, and then we'll go to the final set of problems, and I have some amazing collection of problems which is just going to blow your mind. Okay, so let's get started. Longitudinal axial magnification done, power. Now what is power? Power is the rate of, the degree of convergence or divergence. So simply put, what is power? Power tells you, how the degree of convergence, okay, convergence or divergence. Now, divergence, okay. Now, if it is more converging, it has more power. If it is more diverging, also it has more power, but power has its own sign. What is the sign of power? Remember, if it is converging, then it is positive power. If it is diverging, then it is negative power. Meaning, imagine there is a mirror like this and the rays are converging here. There is another mirror, okay, the rays converge directly right over here. This has, more power, and this has less power. This has less power. Oh, sorry, I did it exactly opposite, my bad. Okay, just 1 second. So I'll just do it again. Yes, so if I had, okay, a mirror like this and another mirror, let's say it was like this, the rays are converging very close. Since you can see the converging power is less for this mirror because the rays are converging after a long distance, this has less power, this has less power, and this has more power because it is converging very soon. That's what it is. And the power is always the reciprocal of the focal length. Remember, this has more power, but this has less focal length. This has more focal length. And that's how you define power. If you see it, power is nothing but 1 by f. Power is nothing but 1 by f. But should I put a plus sign or a minus sign? Let's figure this out. Okay. See, go back. Here, in the case of a concave mirror, think the focal length is negative, right? Focal length is negative, but the rays are converging. That means the power is positive. The power is positive. Similarly, if you think about a convex mirror, okay, the rays will go like that. The focal length will be positive, but the power will be negative. That means whatever is the sign of focal length, exactly opposite will be the sign of the power. That means power is not 1 by f, but indeed it is minus 1 by f. Very, very important. Minus 1 by f. Please understand that. And this is only for mirrors. For lenses it is 1 by f. For mirrors it is minus 1 by f. Got it, my warriors? Understood? And power has the unit of diopter. This is basically your SI unit. That is when focal length is in meter. So when focal length is measured in meters, the power is always in diopters. Understood, my warriors? Understood, my army? Got it? Yep. I'm pretty sure many of you do not or did not know about this before, especially for mirrors, because many students only learn it for lenses and they don't know that there is power for mirrors as well. Okay, so this is how it comes. Let's start solving some questions coming up on your screen, and here it is. We have an object and we have a concave mirror. Both are approaching each other with velocities of 10 and 5 meters per second respectively. Speed of the image of that object at the instant shown is how much? The magnitude of the focal length is 10. This is a concave mirror. Okay, let's think about it. What do we do? See, we want to find the image velocity. In order to find image velocity, what do we do? Vi by Vo is minus V square by U square. So for that, what do I need to find? I need to find V. So for finding V, how do I find it out? Obviously, mirror formula. So obviously I need to use mirror formula with proper sign convention. So let's start doing the question. So first of all, what is the object distance? The object distance is minus 15 centimeters. Okay, minus 15 centimeters. The focal length, it's a concave mirror. The magnitude is 10, but with the signs, it will be minus 10 centimeters. So if I use 1 by V plus 1 by minus 15 is equal to minus 1 by 10. So 1 by V is equal to 1 by 15 minus 1 by 10. The LCM will be 30. So this will be 2 minus 3 divided by 30, which is nothing but minus 1 by 30, I suppose. So V will be minus 30 centimeters. Correct? Are you guys getting it? V is equal to minus 30 centimeters. Perfecto. Now, what next? Let's find out VI by VO, image velocity by object velocity. VI by VO, it is nothing but minus V square by U square. So it will be minus of V square by U square or V by U whole square. So that's basically minus 30 divided by minus 15 whole square, which is just going to give me minus of 2 square, which is nothing but minus 4. Okay, so I'm going to get it as minus 4. Now comes the tricky part. Observe this carefully. See, the object is moving towards the mirror, but even the mirror is moving. That's the problem. So whenever you see the mirror moving, what have I told you? Always sit on the mirror. Always make yourself positioned on the mirror. So when you sit on the mirror, you are going to see the object coming towards the mirror with how much speed? Think and answer in the chat box. Object is going with 10, mirror is coming with 5. So what is the relative velocity? Think and tell me. Isn't it 10 plus 5? So isn't it 10 plus 5, which is 15 meters per second? From this, I can find the image velocity. So image velocity by 15, magnitude wise, or no, not even magnitude wise, all right, just direction wise also I'll get if I put it with minus 4. So VI turns out to be minus 60 meters per second. What does this mean? VI is minus 60 meters per second. It means the image, look at this, the image is moving this way. The image is going this way with 60 meters per second. Perfect. Image is going this way with 60 meters per second. But that is all with respect to the mirror. What is this frame? This is with respect to mirror frame. With respect to the mirror frame. This is with respect to the mirror. Do not forget that. But the mirror itself is moving with 5. Think, for the mirror, it's moving with 60 meters per second. 60 that way. For me, it moves 60 meters. I myself move 5 meters in 1 second. If I move 5, for me, this moves 60. For you, how much did the image move? For me, it moved 60 and it further moved 5. So totally, for you guys, it has moved 60 plus 5, which is 65. Got it? I hope this is clear. So the actual velocity of the image with respect to the ground frame will be minus 60, minus 5, or basically you can say in that same direction, which will be minus 65 meters per second, which is basically option B, I suppose. Is that understood, my warriors? What a brilliant question, because you have to change the frame from mirror and then again come back to the ground frame. Without that, you cannot solve this question. In the negative, because it's going to go that side. Okay, A option is just there to confuse you, and many students might make that mistake, silly mistake. Oh, I think the option mentioned here is wrong. Okay, here only it is mentioned wrong. This should be correct. Okay, just ignore that. Yep, option B is correct. All right, so I'll change it later on. Next question, brilliant question again. Here you have some random object which is placed over here. There will be 4 diagrams in the option. I have not shown you the options deliberately. We need to figure out what kind of shape will it look like and how will it be positioned. That's what it is. Okay, it's all about how will the shape look like and where will it be positioned. Okay, first of all, the object is beyond the center of curvature. I'll write down over here. The object is beyond the center of curvature. If the object is beyond C, where will the image be formed? Therefore, what will happen? The image is formed. Where will it be formed? between C and F. Isn't that right? It will be formed between C and F. Not just that. Yes, we provide 11 standard science classes as well. This is the complete JEE channel, okay? All the things. Next thing, it will be also inverted and it will be diminished. It will be inverted as well as diminished. Interesting, very interesting. So I have to flip this and make it small. Okay, let's just mentally picturize this, how it's going to look. Okay, let's just flip it and make it small. So a smaller thing like this and yep, something like that. Okay, something like this. Okay, perfect. Just ignore the proportions and B will come below. This will be A and E will come below and this will be D. But that's not all. If you draw this diagram, for sure, pakka, you will get a 0 marks or negative marks. Okay, this is not the correct answer. Why? We have missed something. You know what we have missed? There might be a magnification like that along the principal axis as well. Yep, we completely forgot about it. So we need to write that down as well. So think, what is the magnification along the principal axis? The longitudinal magnification. It is minus V square by U square. Now V square by U square is always a positive number. It's always going to be positive. So it's basically negative into always a positive number, which means it will be always negative. If it is negative, what does it mean? It means if the object is facing this way, the image will always be facing the exact opposite way. You need to flip it along the principal axis. Did you guys understand? Because of that negative sign along the principal axis, for longitudinal magnification, it will be always flipped up, inverted. Yes. So take this D on this side, take the AB on the other side. Let's draw it. DE should be over here. Okay, DE should be over here. Okay, so this is D and this is E, and AB should be over here. This is where AB should be. This will be A and this will be B. Now you just join this. That's it. That's enough. This is how the final image will look like. Now this will be correct. What a brilliant question, isn't it? So you have to flip it this way as well as this way and write it with the correct order. That's the final answer. Okay, so A, B, D, E. So that's what you have done. A, B, D, E. Correct. This is how it is going to look like between C and F, and it's going to be small. Okay. I have said that to write it on the paper to solve these questions, to write on a paper to solve these types quickly. I didn't quite follow you, Arjun. What do you mean by that? This is just by practice. Okay. It's not like it will click to you on day one. It will take a lot of time. But next time, if you see a question like this, next time they might give you another question. I don't know. Maybe they might give you some convex mirror, and maybe, I don't know, they might just give you a diagram like this. You know what to do next. Or even if they give you a triangle and a mirror, you know what to do next. It's simple. Okay. So when you solve different question style, that's how you save time in the actual examination. Okay. Yep. Hridaya Shukla, I'll definitely help you after this session. Moving on to the next question. Brilliant question. There are 3 questions coming up on your screen. The first question. All right. So there is a square ABCD of side 1 millimeter at a distance of 15 centimeter in front of the mirror as shown. The focal length is 10. The length of the perimeter of the image. My goodness, the perimeter of the image. What a brilliant question. First of all, you need to figure out how is the image going to look like. Mind it, from my previous question, I understand this object's image might not just be magnified like that, but it could be also magnified in this direction. So, when you find the perimeter, you need to know the length, the height, everything. So, you need this magnification and this magnification. To find magnification, what do you need? You need V and you need U. And I think I already have U. U is 15 centimeters. It's already mentioned right over there. So let's start doing the question. So U is minus 15 centimeters. Focal length is minus 10 centimeters because it is concave mirror. So 1 by V plus 1 by U, which is minus 15, is equal to 1 by minus 10. So therefore 1 by V is equal to 1 by 15 minus 1 by 10. LCM is 30, so it will become 2 minus 3 divided by 30, which is minus 1 by 30. So V will become minus 30 centimeters. That's what I got. Next, we'll find both the magnifications. The magnification perpendicular will be minus V by U, which is minus of V. V is 30 and U is 15. So their signs don't matter anyways. They will get cancelled now in this case. So it will be nothing but minus 2. And the magnification along the principal axis, which is minus of V by U whole square, will be minus of 2 whole square, which is minus 4. Perfect. We got this. Once I get the magnification, I think I'm going to draw how the image is going to look like. So my image, okay, how will it look like? Think carefully. The square, this was a square of side 1 millimeter. This was a square of side 1 millimeter. If you stretch it height wise 2 times, so the height will be 1 into 2, which is 2 millimeters. Everybody agrees with this. Everybody agrees with this because it will be stretched 2 times. And the breadth along the principal axis 4 times. So 1 will be stretched 4 times. That minus does not matter because if it is stretched this way or that way, doesn't matter. The length is the same. So this will be 4 millimeters. So what I have got is no longer a square but a rectangle. So the square has become a rectangle in this situation. And now the perimeter will be nothing but 2 plus 4 plus 2 plus 4. 2 plus 2, 4. 4 3s are 12. So 12 millimeters. That's the answer. Is it there somewhere? Yes, it is. This is the answer. So the brilliant thing about the question was, you needed both the magnifications, one along the height, one along the length, and then you need to re-visualize how the image is going to look like. It looks like a rectangle, so length plus breadth plus length plus breadth, that's going to be the answer. What a brilliant question. Did you love this? Well, if you have loved this, now you're going to love the next question as well. Let's do this question. Observe. Very good, Ankit, unknown, Ishwar, excellente. Guys, if you're loving this question, I hope you have already smashed the like button. Yep, do that. It will give me that motivation to put more such questions for all of you. Hi, Jairoop. There is a concave mirror of focal length 25 centimeter. It faces a plane mirror separated by 30. How far should an object be placed from the plane mirror so that the image formed by the concave mirror after the reflection from the plane mirror coincides on the object itself? The wordings are confusing. Advanced type of question. Thank you, Ankit, so much. And I really appreciate so many of you liking the video even before the session is played. It just shows your love for this channel and how eager you are to learn. Thank you so much. It means a lot. Trust me. First, ignore the second part. Just visualize what might be happening. Concave mirror is there. Forget the focal length. It's placed in front of the plane mirror. Concave mirror in front of the plane mirror, and there is an object in between them. So just think about a concave mirror and a plane mirror and the object in between them. Okay, so there is some object right over here. Okay, so this is the object. Fair enough. This is our object. Okay, and do I have white color? Yes, I do have white color right over here. So this is the silvered side, and yeah, this is also the silvered side right over here. Now observe the second statement. The image formed by the concave mirror after reflection from the plane mirror. What is the meaning of that? It just means that the rays of light, okay, you have to find the image after the concave mirror. Okay, read the statement carefully. The rays of light will first fall on the plane mirror, then the concave mirror to get the final image. I will repeat. See, observe this. You have to find the image formed by the concave mirror after reflecting from the plane mirror. That means after it reflects from the plane mirror, then it will get reflected on the concave mirror and then you will get the final image. So the rays of light will travel from the object. I'll just draw it here. The rays of light will travel something like this, will travel like this, and then it will go like that. But it's clearly mentioned it coincides on the object. That means after doing all this nonsense, the rays will finally come back on the object itself. Very interesting. So the rays goes like this, and it comes back onto the object itself. That's what is happening. Is this now clear? Is this now clear? Everybody got it? Hi Turom Tran, welcome. Okay. Now there is one interesting thing which I told you about mirrors, plane mirrors. What does a plane mirror do? Whatever is there in the front, it will just replicate it behind. This plane mirror, when it is reflecting this ray, all it's doing, it's going to replicate whatever is there in the front behind of it. It's just going to replicate behind of it. So instead of showing the mirror, it's better for me to forget the mirror. Forget the mirror and think as if the rays are traveling in a straight line. So whatever is there in the front will be behind. So instead of the concave mirror here, think of a concave mirror right over here. Think of a concave mirror right over here and then ignore this mirror. Ignore this mirror. This is the reflected concave mirror. This is the reflected concave mirror. That's what I am doing. So you have to ignore this. Okay, you have to ignore this mirror is there. If you ignore that the mirror is there, that means the rays of light are just going to go like this. They're just going to go like this. And I think I know now when would the image be formed? When would the image be formed on the object itself? Do you guys know it? Do you guys know it? I think I just gave you the rule some time back. The ray which passes through some point just retraces the same path after reflection. And which point is that? Which point is that, my warriors? Come on, come on, come on. Tell me, tell me, tell me. If the ray is going, hitting the concave mirror and coming back at the same point, which point is that? Is it focal point? Is it a pole? Yes or no? It is the center of curvature. So this point is nothing but C. This is the center. This is the center of curvature. This is the center of curvature. Perfect. Now rest is just simple geometry. Let's do the math. Okay, the concave mirror focal length 25. If the focal length is known, f is 25 centimeters magnitude wise, and remember r is equal to 2f. Therefore, r's magnitude will be 2 into 25, which is 50 centimeters. That means the center of curvature right from here till here, this distance is 50 centimeters. Fair enough. 30 centimeters is the distance between the concave and the plane mirror, the separation between the plane and the concave mirror. So this distance is nothing but 30 centimeters. But since this mirror gets replicated behind, plane mirror object distance is image distance. So clearly this is also 30 centimeters. Correct? Got it? So the whole thing, how much is the whole thing? 60 centimeters. From here till here, 30 plus 30, that's 60 centimeters. Out of that, this much is 50. This much is 50. So how much is this much? How much is this much? This much will be 10 centimeters. So I got the final answer. So what's the final answer? Where should the object be placed? Where should the object be placed from the plane mirror? So from the plane mirror, how far should it be placed? This is 10, this is 30. Obviously it is 20 centimeters. That should be the answer. Got it? So from the plane mirror, it should be at 20 centimeters. Got it, my warriors? Did I use even one formula? Let me know in the chat box. Did I use even one calculation, mathematical calculation, integration, derivatives, crazy multiplication, division? No. What did I do? I just have drawn the diagrams, ray diagrams. Did I not tell you ray diagrams are important? That's why I told you. If you are having the habit of drawing the ray diagrams, all this will click very easily. That's all. Perfecto. Simple geometry, nothing else. Nothing I've written on the board. Perfect. Very good example. So 20 centimeters is the answer. Let's go to the brilliant question for today. We have multiple mirrors, concave, convex together. So we had concave and plane. Like I promised you, towards the end of the class, we are going to have combination of mirrors. And here it is. A concave convex mirror's focal lengths are given, placed at distance of 70 from each other. Object of height 2 centimeters is placed as shown. Now the question is basically, find the final nature, the size, everything of that image. Okay. But where is the ray incident? First, the ray is incident on the concave, then on the convex. The ray goes like this and then on the convex. That means you should first consider this event. Okay, so the ray will first go like that. Okay, the ray will go like this and then it will go reflect on the convex mirror and then it will form the image somewhere else. Okay, so that's what is going to happen. So think about it. This will be the first mirror you will consider. This will be the second mirror you will be considering. Now for the first mirror, okay, let's try and do this question. So this is for the first mirror. So for the concave mirror. Okay, so this is for the concave mirror. What is the object distance? Object distance is minus 30 centimeters and the focal length. What is the focal length? The concave mirror has a focal length of 10. So focal length is minus 10 centimeters. So let's do the math. 1 by V plus 1 by U is equal to 1 by F. Therefore 1 by V is equal to 1 by 30 minus 1 by 10. So taking the LCM, it will be 1 minus, it will be 3 divided by 30. So this will be nothing but minus 2 divided by 30, which is minus 1 by 15. So V will be equal to minus 15 centimeters. See guys, if you are getting V as minus 15 centimeters. Next, let's also find the magnification and keep. So the magnification in the first case, okay, the magnification in the first case, how much will it be? Minus of V divided by U. U is minus 30. So I'm going to get this as minus 1 by 2. Fair enough. Just keep it aside. Don't do anything now. Now, Jones, I'm already doing one shots for 11th standard. Yesterday I did it, day before, I'm doing it continuously, okay? Thermal physics is going on. So make sure you attend it. Tomorrow we have one shot on conduction. Heat transfer chapter is starting, all right? Now, once you get V is minus 15, try to picturize it. Where is the image formed? Where do you think the image is formed? Minus 15, right? So the image will be formed over here. This is where the image is formed from the first reflection. Got it? Fair enough, 15 somewhere here. Now, this image will become the object for the next reflection. Yes, you heard me right. This image will now become the object for the second reflection. Yes, every reflection's image will be the next reflection's or refraction's object. Next reflection's image will be the next reflection's object. It continues. Now, if this is 15, I'll just write it right over here. If this was 15, think how much is the remaining part? Think how much is the remaining part, my warriors? How much is the remaining part? Can you see that? This is 70, this is 15. How much is it? 70 minus 15, that's 55 centimeters. That's 55, right? Now, please remember, the rays are going like this. The rays are going like this. They are going that way. So this is positive side and this is negative side. That side is positive, this side is negative. But for the first reflection, the rays were going like that. So this was positive and this was negative side. Do you see the change in the sign convention? Do you see this change in the sign convention? What a brilliant thing it is. I'll repeat. In the first situation, this was the object, the white one. The rays will come like that towards this side. Because they are going that side, this side is positive, that side is negative. Fair enough. The rays will go hit, reflect and come back. Reflect and come back. And then they will fall on this mirror like that. They are going like this. So that side is positive and this side is negative. That's how it works. Everybody clear? My army, my warriors, are you clear about it? Let me know in the chat box. Now rewrite everything. What's the object distance in this case? The object distance is minus 55 centimeters. This is for the second case. Okay, this is for the second case. I'll just write it over here. Yep, just 1 second. Yep. So this is for the second case for the convex mirror. So the object distance is minus 55 centimeters. What is the focal length? It's mentioned the focal length is 10 and 15. Since it's convex, the focal point is that side. It's plus 15 centimeters. Very good. Now let's start writing it. 1 by V plus 1 by minus 55 is equal to 1 by 15. Fair enough. So 1 by V is equal to 1 by 55 plus 1 by 15. So 5 is common. So this will become 1 by 11 plus 1 by 3. So this will become 1 by 5. Taking LCM, 11 3s are 33 and 11 plus 3 is 14. So V will be nothing but 5 into 33 divided by 14. I'll just leave it as it is. Maybe some things might get cancelled later on. Okay. The magnification in the second case. The magnification in the second case will be nothing but, check this out, V minus of V by U. So 5 into 33 divided by 14. The whole thing divided by U. U is minus 55. So minus 55. So 55 is 5 into 11. So minus minus cancels. So 5 into 33 divided by 14. And 55 is 5 into 11. 5 goes 11 and 33 goes 3 times. So this will be 3 divided by 14. This is the magnification second time. Got it? Now comes the challenging part. The final image position is what this is. V is positive. That means the final image is somewhere over here. This is your final image. This is where it is. It's on the positive side. Okay, this is exactly what we wanted. Now the nature of the image. The nature is the tricky part. Observe this. First time it got magnified minus half times. First time it got magnified minus half times. Second time it got magnified 3 by 4 times. So the total magnification is M1 into M2. Why is it the product and not the addition? If I tell you the image becomes 2 times and then it becomes 5 times, so the total number of times it gets changed will be not 2 plus 5. It will be 2 times into 5 times. It's times, it's multiplication. So whenever you talk about magnification and there are multiple reflections or refractions happening, then the magnifications just get multiplied. Is that understood? First time it gets magnified 2 times. Then it becomes 5 times of that. So 5 into 2. So that's how it works. So if there are more reflections, it will be M1 into M2 into M3 into M4. So in this case, it will be nothing but minus 1 by 2 into this thing, which is 3 by 14. Yep, so that's going to be minus 3 by 28. Now the moment you look at this, you understand what kind of an image it is. Yep, did you guys get it? Is it not inverted? Is it not inverted? Because it is negative and this number is less than 1. So definitely it is diminished. It is definitely diminished. I hope this is clear. It's definitely diminished. Got it? So this is how this question has to be solved when you have multiple reflections. Now, yep, it's all there over here. Now I have placed some questions right for you in the homework. You need to solve this as assignment. Remember, every class you get homework, you get assignments. This is your second question for homework. Solve it as soon as possible. And this is the third question for homework. And this is your Yeah, 3 questions for homework. Now I'll show you what and all you can get from where. So let me just open up everything right in front of you. Okay, there we go. 1 second. Yep. So when you're watching our channel video, I'll just show it to you. See, just go to playlist. Okay, just go to playlist. When you go to playlist, you have the last minute revision series. These are more like short condensed classes. Here you have the sprint playlist, which is for problems. This is zero to hero, one shot series for so many chapters right over here. You can see that. Okay, so many chapters. Zero to hero series is also there, one shot classes for quick revision. You also have CBSE playlist and all of that. Okay, it's all there over here. Last minute playlist. Okay, KVPY playlist is there right over here. These are strategy sessions, how to score more marks, etc. These are for essay, this is for SX, this is for physics, this is for maths, and so on and so forth. All the playlists are arranged. Okay, you can see that right over here. Pathfinder JEE 2022, that means 12th standard as well as dropper students. So this is for them. Now when you go over here, let's say you go for Pathfinder 12th physics, click on this, and that's me. Go down. Now over here, if you just click on this, you're going to see the entire playlist. Okay, look at this, just go down. Reflection at plane surface, lecture 1, light waves, do you see that? Light waves, electromagnetic waves, lecture 2, electromagnetic waves, lecture 1, light waves is there. This is term 2 syllabus. These are all term 1 syllabus, capacitors, AC, everything, EMI, magnetism, everything, current, electricity, Gauss law, it's all there over here. Okay, so this is where you can find electromagnetic waves. Is that clear? Very good. Oh, Imtiaz, whatever your question is, please let me know. V is equal to, yes, you can use that formula also. It's one and the same thing. Now, if you go below, this is nurture series. This is for 11th standard, exactly similar. If you click on this, you're going to find all the nurture playlists. So just click on this. So when you click on this, you're going to see the nurture classes out here, right from units and dimensions, 1D, 2D, Newton's laws, work per energy, rotation, thermal physics, everything is going to be here. Okay, so that's how you go about the playlist part. Now, when you are watching our video, okay, so when you're watching this video right over here, you will also see other things like this is my Instagram account, this is the Telegram channel. All right, so when you join the Telegram channel, you will get all the PDFs, everything. So you have to install the app, you'll get the PDFs with my handwritten notes, whatever I write over here. For 12th standard, we have many things for you. If you just want to prepare for CBSE, no problem. There is a CBSE term 2 course right for you. But if you want to prepare for obviously JEE Mains plus Advanced, doesn't matter whether you're a 12th or a dropper student, we have a 90 session crash course with 20 mock tests and assignments, which is starting on 17th of Jan. That's hardly few days from now. It's just a few days are over. You can watch the recorded classes as well. But if you want to watch even more recorded classes and you want to get done with this early, then you have the 10th January batch as well. Doesn't matter which you choose, it's the same thing. All the subjects completed. The total price is 10,000 after a discount of 50%, but you get more additional 10% discount and you get this course for only 9,000 rupees when you use my coupon code, and you can see SHCC is applied, you save 1,000 rupees and you have multiple options to pay so. So 9,000 rupees and 90 sessions, that's less than 100 rupees per session. Okay, so I think it's totally worth it, and you can see unlimited doubt solving and continuous support from our side, along with assignments, their analysis, tests, report cards, rank analysis, everything will be provided to you. So this is a very affordable price. I feel you should definitely go ahead and subscribe to this as soon as possible. And if you have already subscribed or you are already a part of Vedantu, and do recommend Vedantu to your friends. This is not just YouTube, but you have to also make use of all the resources that are available to you at your doorstep. YouTube mein, I will definitely be helping you out. But if you want more support, please go ahead, take my word for it. It's definitely going to help and boost your performance in the next few months to come. Don't wait for the JEE Advanced and JEE Mains dates to be announced. Okay, it will be too late otherwise. My blessings, Vicky Roy, are always with you. Thank you, Ankit. And stay home, stay safe. You too, Unknown. Thank you very much and welcome aboard all the new warriors and my new army who has joined today. Thank you for hitting the subscribe and the like button. I can see Hridaya being very happy. Take care and have a great time, unknown. Have a great time, everyone. Bye bye. Do the homework, post it up in the comment section after the video is over. Alright. And if you have loved the dark mode, do let me know that as well. And if you want to change any of the colors, do let me know that as well in the comment section. I'm waiting to hear your feedback. Alright. Thank you very much. Take care. Hasta la vista. This was Captain Shreyas signing off. Bye bye. Take care.